Fuzzy logic. Application of fuzzy set and logic in maritime environment. Kita fokus on fuzzy logic based approach to qualitative safety modeling for risk analysis. Abstract dia, penilaian keselamatan berdasarkan kaedah risiko konvensional mungkin tidak sesuai dengan kebanyakan masalah. Disebabkan kurang yakin dengan data yang tidak dapat dielakkan, hilang atau tidak lengkap dalam penilaian keselamatan, so kita guna teknik penilaian keselamatan dan risiko umum untuk industri maritim. Therefore, logic based berasaskan logik karbo mungkin lebih atau sangat sesuai digunakan dalam menjalankan penilaian keselamatan untuk sistem maritim. Introduction ni pasal history about fuzzy set theory. Okay, fuzzy set theory ni diasaskan oleh Zadeh pada tahun 1965, berurusan dengan ketidakpastian kerana ketepatan dan kekabaran telah digunakan secara meluas selama 40 tahun yang lalu. Fuzzy set theory ni telah di-apply dekat banyak masalah. Dan ada beberapa application fuzzy set theory ni. Okay, fuzzy set theory linear and non-linear programming, dynamic programming, safety, risk, reliability, decision making, decision support system and expert system. Fuzzy set theory bantu improve our simplified models and menjadikan lebih kuat dan fleksibel model untuk real world complex system, especially those involving human aspect. Fuzzy set theory ni signifikan bila apply kepada fenomena yang kompleks yang suka digunakan dalam kaedah matematik, terutama untuk mendapatkan penyelesaian yang tepat. Okay, ni just overview of the qualitative safety model for risk analysis. And ni rangka kerja keselamatan umum untuk analisis risiko menggunakan pendekatan berasaskan logik fuzzy. These three are overall safety model. First, submodel keselamatan yang berkaitan dengan orang. Ni second, submodel keselamatan berkaitan dengan alam sekitar. Dan submodel keselamatan organisasi atau perniagaan yang berkaitan. This figure menunjukkan failure likelihood untuk very low, low, reasonably low, average, frequent, highly frequent. Setiap tahap ni ada maksud-maksud dia. Very low untuk failure dia unlikely, tapi boleh je berlaku bila-bila masa. Untuk low, dia boleh failure dalam sesuatu masa. Reasonably low, antara low dengan average failure dia. Average, sometime failure, frequent, failure to repeat. Highly frequent, setiap masa dia failure. Okay, this figure about consequence severity. Severity ni tentang tahap kerosakan kapal. Negligible, maksud dia tiada kerosakan. Minor, single atau minor kerosakan dia. Moderate, multiple kerosakan. Severe, multiple severe injuries. Catastrophic, large number of injuries. Ni tahap-tahap dia lah. Then tentang tahap risiko, risk level expression set definition. Untuk low ni maksud dia good safety, possible, average safety, substantial, fair safety and high, poor safety.
Next slide ialah steps. Step 1 is falsification of input variables. Langkah pertama ialah mengubah input yang renyah menjadi darjah perlawanan dengan nilai linguistik melalui fungsi keahlian. Proses falsifikasi ini dilakukan oleh fungsi keanggotaan pra-diperoleh untuk pemboleh ubah input dan output yang boleh mempunyai pelbagai jenis, seperti bentuk segitiga, trapezoid atau gelombang Gauss. Figure yang diterangkan di atas iaitu failure likelihood, consequence severity and risk level dapat disimpulkan dengan beberapa rule. Terdapat hanya 4 rules are fired contributing to ensure evaluation process. First rule is, if the failure likelihood is average and the consequence severity is severe, then the risk level is substantial. Second rule, if the failure likelihood is average and the consequence severity is catastrophic, then the risk level is substantial. Third rule, if the failure likelihood is frequent and the consequence severity is severe, then the risk level is substantial. Last rule is, if the failure likelihood is frequent and the consequence severity is catastrophic, then the risk level is high. Step 2 is application of fuzzy operator and or in antecedent. Nilai and or ini akan digunakan pada fungsi output. Input ke operator kabur mungkin mempunyai 2 atau lebih nilai keahlian dari pemboleh ubah input kabur. Output adalah nilai kebenaran tunggal. Step 3 is implication from antecedent to consequence. Contoh dia, bila operator AND, so output kita akan ambil smallest or minimum rule antecedent. Step 4 is aggregation of consequence across the rules. Then the output, setiap rule yang dah diterangkan digabungkan, aggregation of consequence across the rules is, then the output of each rules is combined into a single fuzzy set through aggregation process. Finally, step 5 is defuzzification. Fuzzification ni ditransform in fuzzy results into a crisp output. Given a membership function ni, and the defuzzified output can be calculated as this formula. Methodology, fuzzy sets and membership functions. Given a space of objects X with X belong to X, a fuzzy set A in X is characterized by a membership function mu A of X, X01 with mu A of X representing the grade or membership of X in the fuzzy set A. Given two fuzzy sets A, B belong to X, the classical set operations include the complement, intersection and union. For Xi belong to X where I equals 1, 2, 3 until n, and X being a discrete and finite space, the mapping of the fuzzy set A is denoted by this. Given a continuous and infinite space X, the fuzzy set A can be expressed as A equals to mu integration of mu A of X over X dx. With the classical set operations and X belong to X, the operations for fuzzy sets A and B are defined as, this is for complement, A power of C of X equals to X over A. This is for intersection, A Intercept with B equals to mu A of X. Intercept with mu B of X equals to minimum of mu A of X and mu B of X. Intercept of union of A and B equals to mu A of X union with mu B of X equals to maximum of mu AX and mu BX. Fuzzy model for estimating a safety index. The Maritime Safety Index consists of combination of a collision and a grounding index, each represented by a proposed fuzzy model. By following the definition of the input variable, the membership function for the fuzzy models estimate a collision and grounding index are created. The fuzzy models estimate a safety index for a specific vessel, the own ship, at a specific time. In the vicinity of the own ship, one or several target ships could be present to affect the collision theory safety index. Land or shallow waters nearby could affect the grounding safety index. Safety margin. The safety margin input parameter regulates the under keel clearance to be safe for the specific ship. This figure illustrate the safety margin. Input parameter has 5 membership functions, which are very permissive, medium, restrictive, and alright. This figure is the calculation of the collision safety index in 4 different modules combined, which is first, geometrical probability, environmental conditions, 2 vessel safety index, then collision safety index. Validation and results. Yang pertama, model disahkan melalui senario yang dijalankan dalam simulator pengendalian kapal dan dinilai pada setiap 1 minit. Instruktur akan diberitahu untuk menilai keadaan trafik dari perspektif kapal itu. Kemudian, senario ini dilakukan untuk tinjauan pakar apabila perlu. Akhir sekali, nilai purata instruktur dalam senario akan dibandingkan dengan nilai output yang dikira dalam safety index model. Conclusion. Fuzzy logic has received substantial attention in addressing decision-making in maritime shipping on the strategic, tactical and operational level. In addition, it is possible to observe that fuzzy logic methodologies have been widely applied in economic assessment contributions such as port performance and efficiency, as well as risk management. The fuzzy logic approach offers a great potential in safety modeling of maritime system. Risk analysis using fuzzy logic approach can formulate domain, human experts, experience and safety engineering knowledge. Lastly, the results of provides safety analysis and designers with a convenient tool that can be used at various stages of the design process of maritime engineering system. That's all for this presentation. Thank you.